Welcome to today's lesson, students. Let me clear my throat for a little bit. Today's lesson is going to be naming and writing covalent compounds. And so that's what we're going to be talking about today. But first, go ahead and grab your worksheet and answer the following ACP prep question. It's on physical and chemical changes. So your question is, which statement is a chemical property of copper? Go ahead and pause the video and give the answer that you think. Okay, so the answer to the question, which statement is a chemical property of copper? The answer is C. It reacts with nitric acid. And the key word is, first of all, if you read the question carefully, it says, what is a chemical property? So a chemical property is a characteristic about matter that describes its ability to change into a new substance. So the key word for this would be react. Anything that has to do with reactivity is talking about the ability to change, okay? If you were to, the other ones are not chemical properties. So malleability and ductility are actually physical properties, okay? Physical properties. Liquid, so like a melting point, that's a physical property, okay? And then the fact that it's a mineral is just saying what it is, so that's not a chemical property, okay? So, I thought that it's important that we start preparing now. We have a month until the ACP, so it's good to go ahead and get into that mindset. So typically I would have had you take 2 minutes, but we're not going to do that. So here's a list of physical and chemical properties, and I'll let you pause the video and read them, okay? In the interest of time, let's go ahead and move on. So today's lesson, like I said, is on naming and writing, and it should be covalent compounds. I'm going to go ahead and change that title. Covalent are otherwise known as molecular compounds, okay? Next class, we're going to talk about ionic compounds. And you'll forgive me, I've had a little bit of a cough, but let's go ahead and get started. So try to focus on this right-hand side. You see where I'm putting some stars and where I circle it? This is what we're going to be talking about, covalent or molecular compounds. Today, you'll need a periodic table of the elements. You'll need your brain, obviously, and a pencil. You'll need access to my Google Classroom in order for you to do your demonstration of learning for today. And as you know, you should be bringing your laptop with you daily for these very purposes. What is your learning goal? Your learning goal is to be able to name and write compounds using IUPAC rules. So IUPAC is just an international chemistry organization, okay? These are very important people, really, really smart. They got elected or whatever you want to call it. And these are the people that set the rules for chemistry, how we name these things, okay? So naming a compound is actually writing the actual word out. And then writing a compound is writing the symbols and the numbers that go along with it. So we're going to be talking about this. Success criteria. By the end of this lesson, if you are able to say yes to all of these things, that means that you're on the right track. And if you're unable to, it means you need to go back to the drawing board, go back and watch this video, search for more videos on this topic, or come to tutoring, okay? So here's the success criteria. I understand the nature of covalent or molecular bonds. They're the same thing. I understand the number prefixes. I understand the "ide" ending in covalent compounds. I can write and name covalent and molecular compounds. So, quick review. Covalent bonds are between two nonmetals. I think that I've tried to establish this for several class periods now. So you have to understand that covalent bonds are between two nonmetals. Very, very important. Because when you're looking at a chemical compound formula like this, you need to be able to understand that these are two nonmetals, okay? So here we have phosphorus and we have oxygen, O, okay? Both of these are nonmetals, and you should know what the metals between the nonmetals, because you have boron on the periodic table and then you do the little step case, okay? Everything to the right of that line that I just drew is a nonmetal. Everything to the left is a metal except for hydrogen. Hydrogen is a non-metal, so be aware of that. Anyways, covalent bonds are between two nonmetals. Now let's look at the molecular formula. The molecular formula will tell you, and this is the molecular formula, okay? That's what I just circled. The molecular formula will tell you how many atoms of each element there is. So here we have P2O5. What elements are in this bond, and how many atoms of each do we have? We have phosphorus, okay, so I'm going to circle the P. We have phosphorus, and this little 2 subscript underneath tells us that we have 2 atoms. This number, anytime you see an element symbol and you see a little subscript number, it's kind of like a little number just a little bit below it to the right that tells you how many atoms of that element there is. So we have O, that's oxygen, and this little 5 tells us that we have 5 oxygen atoms. So in this entire chemical compound, we have 2 phosphorus atoms and 5 oxygen atoms. So it's very important that you understand how to read a molecular formula, because if you don't know what that means, P2O5, then from the get-go, you're not going to get it right. So you need to be able to understand that. And if you don't, you need to pause this video and then go research some more on YouTube or on the internet, how to read a chemical formula, okay? This is just a quick reminder what I was telling you. The metals and the nonmetals on the periodic table. Once again, the periodic table that you have has a thick line, okay? And I'm going to actually change colors to orange, okay? So here's the line on your periodic table, but I'm highlighting it with orange, okay? So that you can't mistake it, okay? You start with boron, okay? And to the left and underneath boron, there's a staircase. Everything to the right of that staircase that I'm shading with lines are non-metals, okay? Everything to the left that I'm putting a star by, okay? It's an ugly star. Everything here that I'm doing in straight lines, these are the metals, okay? And don't forget, there's one exception. Hydrogen is a non-metal. But that line that I just drew, very important line, that's the line of demarcation, okay? So once again, I'm going to highlight it. Everything to the left of this line that I'm highlighting is a metal except for hydrogen. And everything to the right that I just crossed out is a non-metal, okay? So try to understand that, okay? While I switch colors here. There we go. Okay. Covalent compounds use numerical prefixes. So based upon the number of atoms, we're going to use these prefixes to symbolize how many of each atom we have. So on your paper, there's a spot on your worksheet in order to write these prefixes, and you have to memorize these. I wish there was some way to tell you that, oh, it's okay, you don't need to memorize these, but unfortunately you do. But I think the only good thing about this is I believe that throughout your life you have seen these prefixes so often that they might come back to you, okay? So, 1, we're going to use the prefix mono. 2, we're going to use di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10, deca. So go ahead and pause the video and then fill out your worksheet with these prefixes, okay? All right, so we're going to go ahead and move on to, we also have a little bit of semi-name transformations in covalent compounds, okay? So typically in high school chemistry, when it comes to the ACP exam, we tend to just stick, we do deal with polyatomic ions, but when it comes to naming them, I believe we're just going to stick with 2 elements. And so that second element is going to transform from its normal name to an ending that ends in "ide." So please write the name changes on your worksheet. You may have to pause the video after I explain this, because after I do this, I'm just going to keep going. But if you're working from home and you're trying to do a missed assignment, pause this video so fluorine switches to fluoride. So you can already tell right now that fluorine, instead of fluorine, it becomes ide. Chlorine transfers to chloride. Bromine transforms to bromide. Iodine transforms to iodide. Oxygen, probably one of the biggest transformations, goes from oxygen to oxide. But I think you've heard of oxide before, right? Carbon dioxide, carbon monoxide. You're used to this, right? Sulfur becomes sulfide. Nitrogen becomes nitride. That's kind of a big transformation. And phosphorus becomes phosphide. So you might have to pause the video in order to write these name transformations. So essentially, just remember ide, okay? Try to remember that. That is the second element name. And my handwriting needs to get better. Second element name change, okay? So how do we name chemical compounds, covalent compounds? This is the formula, okay? Sometimes you have to name the compound like we're doing now. You actually have to write the full names of these. Other times it's in reverse. Other times you get the name and you have to write the formula, symbols and numbers, but we're practicing naming them, okay? So what are the rules? The first rule is for the first element, you want to start with the regular name. So in this particular compound, we have phosphorus, okay? So P. So you're just going to write the regular name, phosphorus, okay? Nothing fancy. You don't have to do anything. Rule number 2, for the second element, you're going to use its new transformed name. So the second element is oxygen. But remember, oxygen transforms from oxygen. And if you look at your list, it turns from oxygen to oxide. So now we have both of our names. The first element is just a regular name. And then the key to this is oxygen has now become oxide. Okay, moving forward. The third rule, add number prefixes to show how many atoms each element has. So let's look at the molecular formula, okay? We're going to pay attention to the numbers that are by each element. So let's look at phosphorus first, okay? Phosphorus has a 2 by it. So we have 2 phosphorus atoms in this compound. So you go to your prefix chart and we use the prefix di for 2. So we're going to add di in front of phosphorus. So we had phosphorus, but now it becomes diphosphorus because it has we have 2 atoms of phosphorus. Now let's look at oxygen. Our molecular formula tells us that we have 5 oxygen atoms. So what's the prefix for 5? Penta. So We're going to put that in front of oxide. And normally we would say pentaoxide, but we get rid of the A and it becomes pentoxide, okay? So, pardon me. This is the correct way to name P2O5. The correct covalent compound name is diphosphorus pentoxide. Hopefully you learned. This is starting to get the gears in the brain working, okay? Well, let's look at another example. First, there's an exception that I want to talk about. Do not use a prefix for the first element if there is only one atom of it. For example, let's look at carbon dioxide. Or actually, CO2, and I shouldn't have given it away. See, I've been doing chemistry for so long, I'm just naming it when I shouldn't. So let's look at CO2, okay? This is the formula. This is the molecular formula, okay? So, let's start with our rule. For the first element, you start with the regular name, okay? So what's our first element? Our first element is C. That is carbon. We're just going to write carbon, and we're going to leave it at that. What's our second element? O. That's oxygen. But rule number 2 says for the second element name, we're going to use its new transformed "ide" name. So oxygen will become oxide. Rule number 3, add number prefixes to show how many atoms each element has, okay? So typically, let's look at C. Pay very close attention. There is no number, see? There's no number below, like right by C, a little bottom subscript. That means we only have one of it. The prefix for 1 is mono. So you would think down at the bottom, under rule number 3, we would have monocarbon, right? But here's the exception. Do not use a prefix for the first element if there is only one atom of it. So you would think it would be monocarbon dioxide, but look what I did. I went ahead and scratched it out, okay? So we're left with carbon because there's only one of it. Now, for the second element, we can add the prefix. So our second element is oxygen. There's 2 of them. And so the prefix for 2 is di. And we're going to go right and put it right in front of oxide, dioxide. So our original chemical formula was CO2. And let me put that in a box. The correct name for it would be carbon dioxide. And I use this example to show you the exception to the rule. I think we have another example. We do. What is the name of the molecular compound with the formula N2O4? So let's start out with our rules. For the first element, you start with the regular name. So looking at this molecular compound, our first element is a symbol of N. So that's nitrogen. So we're just going to write nitrogen because for the first element, you just write it as we know it, okay? Nitrogen, nice and simple. Rule number 2, for the second element, you're going to use its new transformed "ide" name. So our second element is oxygen. So oxygen becomes oxide, okay? Hopefully that's becoming easier for you to understand. Now what we do is we add, for rule number 3, number prefixes to show how many atoms each element has. So let's look at nitrogen. There's a 2 subscript, so we have 2 nitrogen atoms. The prefix for 2 is di. So in front of nitrogen, we're going to put di, so it becomes dinitrogen. Let's look at oxygen. With oxygen, we have 4 oxygen atoms. The prefix for 4 is tetra. So in front of oxide, we're going to put tetraoxide, but we get rid of the A and it just becomes tetroxide. Okay, even I had some trouble pronouncing it. So for the formula N2O4, The correct name is dinitrogen tetroxide. Very well, and I hope that this has helped you somewhat, these examples. What happens if you have to go in reverse? What if you're given the name, such as carbon tetrachloride, and you have to write the formula? Just go in reverse. So rule number 1, you write the symbols of the elements in the compound. So here we have carbon. So what's carbon symbol? A C. And I'm going to write this in the left-hand side. We have chloride, okay? Chloride was transformed from chlorine, right? So we know that that was a chlorine, and we know that the symbol for chlorine is 4. So we're going to put a little Cl there. And then add subscripts to each symbol based on the prefix. So we look at carbon. Remember, if there's no prefix before carbon, we know that there's only one of it, because if there was one carbon element, we can't say monocarbon, we only say carbon. And since there's no other prefix attached to it, there's only one of it, so we're going to leave it as C. Chloride has a tetra in front of it. You see that? Let me go ahead and erase what I've been working on. Let's look at the name, tetrachloride. So this prefix tetra is a big giveaway, and that's why you have to understand what these prefixes mean. Tetra is the prefix for the number 4. So what are we going to do? We're going to put a 4 right as a subscript by chlorine, and this is the correct formula. So let's go ahead and start from the beginning. The correct molecular formula for carbon tetrachloride is CCl4. Okay, so this is just a quick recap on naming and writing covalent bond rules. First, name the first element using the element's normal full name. Okay, nothing fancy about it. Rule number 2, for the second element, name the second element using its new transformed ide name. So refer back to that list that you just created, okay? It's going to take some time, but I hope that with time, and I believe that with time, you're not even going to have to look at the list, because all of them basically end in ide, and then you'll get the hang of it as time goes on, okay? Number 3, once you have your 2 names, then you add prefixes to show how many atoms of each element is present. But don't forget that you do not use the prefix mono on the first element. So the real key to writing and naming covalent bonds is understanding the numerical prefixes in the new ide names, okay? So what I'd like for you to do, here's a video that I'd like you to watch. And I'm not actually going to have you watch it, because I included that link on the Google Classroom. So watch that on your own time to maybe help you understand a little bit more if I'm not making sense to you. I don't claim to have all information or even be the best presenter of this information, okay? So maybe this guy or girl can help you understand better. So what I'd like for you to do is, on your worksheet, there's some independent practice on the backhand side. I'd like you to spend 15 minutes to work on this. Complete the self-practice on naming and writing covalent bonds. And since you're doing this at home, or you're doing this in another place other than my classroom, I won't be available at the help station to help you, but you can even take more than 15 minutes, okay? So go ahead and pause the video and work on the independent practice on the back side of your worksheet. Okay, so you've completed it. What I'd like for you to do is take 5 minutes, or in this case, you've lucked out because you're not in the class, there's no time limit. Go ahead and see how you did, okay? How did you perform? And so check your answers and see what kind of a job you did. Remember, this is practice, okay? Practice makes perfect. So in a little bit, you're going to do a demonstration of learning, and that's where your grade's going to come from. So hopefully this was good practice for you. Well, even though you're not in class today and you missed the brain break that all the other students were able to take, maybe you should take a brain break. So feel free to take a little 3-minute breather for all the hard work you've done. So what I'd like for you to do now is to go into Google Classroom for this assignment and click and complete the demonstration of learning, okay? It is a quiz. It is a Google form, and this will be a grade today, okay? The sheet that you filled out, the worksheet that you've been working on, I'd like for you to keep that in your binder, okay? So that you have it so you can study for the ACP, okay? And remember, please do not cheat. Just get on the Google Forms and then do your best, okay? You are able to use a periodic table. You are always able to use that, okay? The last thing I want to talk about is a Thanksgiving booklet. There's a lot of you that are not doing well in the class, okay? Maybe you're either behind, you've missed days due to illness, whatever the case may be, there's a way for you to pass the class right now. Hey, there is hope, right? I have created a Thanksgiving booklet. I want you to, every student, so this is for every student, I want every student to pick up a Thanksgiving booklet and to complete it. Okay? Complete the paper booklet. So it's an empty booklet and you have to fill it out. So where do you go for help, okay? I've included this assignment under the name Thanksgiving Booklet Packet, okay? So you pick up the paper booklet, and then what you're going to do is during the Thanksgiving break, you're going to go to this assignment in Google Classroom, and I want you to watch the YouTube video. I made a YouTube video, and so as you watch this video, okay, as you watch the video, you're going to fill out this packet. You may have to pause it. You have to do whatever you have to do, but that's what you're going to do. And you can go to other assignments. You can go back to the previous classes this year and go on those Google Classroom to help you fill out this packet, okay? It covers all topics from the beginning of school until now. So physical and chemical properties and changes, states of matter, so solids, liquids, and gases, pure substances and mixtures, okay? Modern atomic theory, so J.J. Thomson, John Dalton, Ernest Rutherford. Famous experiments of the atomic theory, so cathode ray tube, gold foil experiment. What did we discover and learn from these? Talks about the Bohr model. It covers electron configuration. It covers the electromagnetic spectrum. It covers periodic table families, periodic trends such as atomic radii, things like that. It covers average atomic mass. It's everything that we've covered. But the bottom line is, if you're failing the class and if you complete this book in the review, your grade will become passing, okay? So, hey, this is your ticket. This is your opportunity. If you're passing the class, I will bump up your exam 3 grade to 100 for doing this assignment, okay? And I'll replace any 0 that you have to passing, okay? This is due when you return from break, okay? So once again, thank you very much for today's assignment. Try to do your best and try to remember this as good as possible. Thank you very much.